In this problem, we're asked to integrate from 3 to infinity the function 2 over v squared minus v dv, and we have an improper integral of type 1. In order to solve this particular problem, the first thing we'll do is we'll pull 2 in front of our integral operator. So we have 2 times the integral from 3 to infinity of 1 over v squared minus v dv. The next thing I'll do is I'll use partial fraction to rewrite 1 over v squared minus v as a sum or difference of fractions. So if you haven't, you may want to watch the previous video on the link listed here, and where I show how to use the partial fractions method. So once we use the partial decomposition, we can rewrite 1 over v squared minus v as negative 1 over v plus 1 over v minus 1 dv. Next, we'll incorporate the limit since we have an infinite limit. So I'm going to write this as 2 times the limit as b approaches infinity for the integral 3 to b for the function negative 1 over v plus 1 over v minus 1 dv. Next, I'll integrate negative 1 over v and 1 over v minus 1. So we have 2 times the limit as b approaches infinity. The integral of negative 1 over v is negative natural log of v. The integral of 1 over v minus 1 is the natural log of v minus 1. And we're going to integrate this from 3 to b. Now, to show where these things are coming from, here I'll show how we can integrate negative 1 over v dv. And I'm simply going to move my negative in front of the integral. And from the basic integral sheet, the integral of 1 over v is the natural log of v. So I have negative natural log of v plus c. So we have written the integral of negative 1 over v as negative natural log of v. I'll also integrate 1 over v minus 1 here to see how that result is given. The integral of 1 over v minus 1 dv, I'm going to use a u substitution. I'm going to let u equal to v minus 1. I'm going to take the derivative with respect to v for both sides. So du by dv. And if I take the derivative with respect to v for the right hand side, I get 1. Therefore, du is equal to dv. And now I can write this in terms of u and du. So I'm going to write this as the integral of 1 over u, because we can replace v minus 1 with u, and we can replace dv with du. And once again, from your formula sheet, the integral of 1 over u is the natural log of u plus c. And keep in mind that u is v minus 1, so we have the natural log of v minus 1 plus c. So we have our result, the natural log of v minus 1. The next thing I'll do is I'll use a fundamental theorem of calculus. The next thing I'll do is I'll use some properties for the natural logarithms to rewrite this as a single log term. So this is equal to 2 times the limit as b approaches infinity And I'm going to rearrange this. So I'm going to write this as the natural log of v minus 1 minus the natural log of v from 3 to b. This will allow me to rewrite the difference as a quotient. So I can now write this as 2 times the limit as b approaches infinity for the natural log of v minus 1 over v from 3 to b. Now I'll use a fundamental theorem of calculus. So first I'll substitute in b. So I have the limit as b approaches infinity for the natural log of b minus 1 over b minus, and now I'll substitute in a 3. So 3 minus 1 is 2 over 3. So we have the natural log of 2/3. If we evaluate the limit as b approaches infinity for the natural log of b minus 1 over b, we see that the limit is 0. So we have 2 times negative natural log of 2/3. So our final result is negative 2 times the natural log of 2/3.